What if one board had 16 modules, all wired up, no breadboard, no soldering, no mess? Today, I'm reviewing the ELECROW All-in-One Starter Kit with Arduino Nano R4 development board to find out if it's actually a good way to learn Arduino. Before we dive in, I want to let you know I'll be giving away this starter kit. Stick around until the end to find out how you can enter. First thing you notice, it comes in this translucent latching carrying case. For a classroom or a maker on the move, that's a real selling point. Inside the carrying case, it comes with a soil moisture sensor, a USB-C cable, the Arduino Nano R4 board itself, an infrared remote control, 3 servo motor arms. Every sensor is already mounted and wired on the board. Let's talk layout, because this is where the design really works. On the top left, connected to D4, is the relay. It's an electrically controlled switch. On the top center is an LCD that displays text. On the top right is the servo motor connected to D9. You send it a position, and it drives there and holds. Below the relay is the buzzer connected to D3. It's the audio output for generating beeps and different pitches. This module features an ultrasonic ranging sensor mapped to digital pins D6 and D7. It serves as the primary module for real-time distance detection and obstacle measurement. Connected to pin A2, this PIR, or passive infrared sensor, tracks motion by picking up on the body heat of anyone or anything moving across its field of view. This is a linear potentiometer connected to A0. It's a sliding variable resistor. On the bottom left is the temperature and humidity sensor. It reads the surrounding air temperature and relative humidity. This is a light sensor. It's a digital ambient light sensor. This module combines a 3-axis accelerometer and a 3-axis gyroscope into a single 6-axis inertial measurement unit. It tracks linear acceleration along the X, Y, and Z axes, while simultaneously monitoring angular velocity to determine tilt, motion, and orientation. This 4-digit digital display provides real-time readouts for counters, timers, sensor data, and scores. This is the central slot of the development board where you will insert the Arduino Nano R4 main board. This module uses 3 LEDs, or light-emitting diodes, that illuminate when current flows through them in the correct direction. This is a sound sensor connected to A1. It's a microphone-based module that detects ambient sound level. All 3 buttons connect to the nano analog input pin A3, which reads the resulting voltage variations to distinguish between button presses. This IR, or infrared receiver, converts light pulses from a remote control into digital signals for the nano to decode. This GPIO interface is used to control devices like LEDs or motors. This UART interface is used for serial data communication. Before you build anything, you'll want to download the user manual. Just head to the product page on ELECROW's website. Once you're on that page, scroll down to the section called User Manual. That manual is really the heart of this kit. It walks you through installing the Arduino IDE, adding the board package, and every one of the 20 lessons with the complete code explained line by line. First things first, let's prep the hardware. Grab your Arduino Nano R4 and insert it into the center slot of the development board. Just make sure the Type-C port is pointing downward. Attach the servo motor arm into the servo motor. Plug one end of the USB-C cable into the device's USB port, and the other end into your computer. Install the Arduino IDE from the Arduino official website. Select and download the version compatible with your operating system. Once installed, open the Arduino IDE app. Click the development board icon on the left sidebar. Type Uno R4 in the search bar. Click Install to install the board. Download the kit's required library files and place them into the Arduino libraries directory before getting started. On the Arduino IDE app, go to the Tools menu, select Board, select Arduino Uno R4 boards, and select Arduino Nano R4. Go to the Tools menu, select Port, and select COM3, Arduino Nano R4. Click the Upload button and confirm the upload was successful. We are ready to begin the practical exercises. Open the 1_led.ino file located in the Arduino lesson code. Lesson 1 focuses on controlling the 3 onboard LED indicators on the Arduino Nano R4. Press the Verify button to check for syntax errors and potential bugs without uploading it to the Arduino board. If there are no errors, press the Upload button to compile your code and send the resulting binary file to the Arduino board. As you can see, the 3 LEDs blink every 1 second. Let's walk through how this code works. The defined lines are basically labels. The 3 LEDs are physically wired to pins 5, 10, and 11 on the board. This is the blink timing in milliseconds. Putting it in a variable means you can change the blink speed by editing this single number instead of hunting through the code. Void setup runs one time when the board powers on. Its job is configuration. Pin mode tells the board that pin is going to send out voltage to drive an LED as opposed to reading voltage in, like it would for a sensor. Void loop runs repeatedly, forever, after setup finishes. Digital write sends a high 5 volts to that pin, which turns the LED on. Delay pauses the program for 1000 milliseconds, so the LEDs stay lit for a second. Digital write drops the pin to 0 volt, turning the LED off. Delay pauses another second with them off. To practice modifying the code, let's change the LED blink rate from 1 second to 3 seconds. To do this, simply update the interval value from 1000 to 3000 milliseconds. The LEDs are now configured to blink every 3 seconds. In Lesson 2, you will use a sound sensor to read analog values and apply threshold detection for a sound-activated hallway light. Simply clap your hands to trigger the red LED, which will stay lit for 3 seconds. Let's walk through how this code works. The sound sensor is physically connected to pin A1 and the LED to pin 5. These lines give those pin numbers readable names. Void setup means to run the app once. Serial opens a communication channel so the board can send text back to your computer. Pin mode sets the LED pin to send voltage out so it can drive the LED. Void loop means to run the app forever. Analog read measures the sensor's voltage and turns it into a number from 0 to 1023, where 0 is silent and 1023 is very loud. Serial print line prints that loudness number to the serial monitor on your computer. The if statement acts as a conditional switch based on volume. If there is a loud sound above 500, the LED turns on, pausing for 3 seconds and turning it off. If there is a quiet sound, 500 or below, the LED remains off. The delay pauses 1/10 of a second before looping back to take the next reading. For more step-by-step guidance, explore the user manual, which features 18 additional lessons. This is a great starter kit. This is a great buy for beginners, parents, teachers, or anyone who wants to learn Arduino. The modules are housed in a compact, portable case. Anyone who's tried Arduino knows the pain of a project that won't work because one jumper wire is in the wrong hole. Here, everything's pre-connected and every module is labeled with its exact pin, so a first-timer spends their time learning code instead of hunting for a loose wire. Now it's time to explain the giveaway. To enter, complete the form linked in the description. In 1 week, I will do a random draw and announce the winner. For full details of the giveaway, please refer to the description. No purchase necessary. Good luck! If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.